All right, so welcome to your lesson on using vectors. Um, for those of you familiar with Despicable Me, remember that vector was the criminal with magnitude and direction. Just kind of keep that in mind while we go through this. So a vector is a physical quantity that has both magnitude and direction. Physical quantity are those things that we're measuring in physics. And so examples of vectors are velocity, displacement, acceleration, and then in just a couple days, we're going to add force to the list, and that would be force. For your scalars, and those are the things that are just magnitude only, just as a quick refresher, you have speed, which tells you how fast, and you have distance, which tells you how far, and you can have other things like volume and time and mass where the direction doesn't really make sense. When we're talking about directions, we kind of have to decide something that makes everybody's make sense together. And so what we have is north is basically pointing towards the top of your paper, or also the top of the board, top of the screen. West goes off to the left, east goes to the right, and south will go down the page or down the bottom of the screen. And if you stick with those, you'll be okay. The whole point would be to be consistent, no matter what directions you choose. And the direction will matter. You will also see positive and negative. And so usually heading to the right would be positive. Heading to the left would be negative. Or if you're going up and down, going down is negative. Going up would be positive. But pick something that makes sense. Now, when you're working with vectors, vectors are drawn as arrows. And they're going to show you how big or the magnitude of it and what direction it's going. And so the one that's shown on the screen already is just a velocity of 60 meters per second east. And if I wanted to show something different, like let's say velocity is 20 meters per second north, I would just draw something a little bit shorter, pointing towards the top of the page, and I would label it. With magnitude and direction. We will be adding vectors, and we're going to do that graphically. And when you're adding vectors graphically, the precision counts. You're going to have to use a ruler. You're going to have to measure carefully. And in order to get a good answer, you're going to have to measure it one more time and be sure you know what you're doing. So in this case, what we've done is we've decided to add two vectors. We have A, and we're going to add on vector B. So the first thing you do is draw it tip to tail. So you can consider this the tail. This would be your start. And you headed this way, and there's the tip of it, and we're going to start a new one. So you can pretend like you wandered around a corner or just turned and headed off in a new direction. And you start with the end of the new one. And head off in the direction that you need to for the length that you need to go. And then what you end up with is you go back to where you started and look at where you ended and measure this displacement, and you'll get the length of the resultant And whatever that length is the answer to the question, what is A plus B? And you'll need to talk about what direction it's heading. One other thing that we do with vectors is we actually talk about finding the components that make up the pieces of the vector. So if this is our resultant vector, it has two pieces called components that make it up. And you can think of these things as the legs of a right triangle with the hypotenuse, with the hypotenuse as the resultant. So in this case, we kind of took it apart. So C is equal to A plus B. And we're using the vector symbol. If you were actually finding lengths and things, you'd use the Pythagorean theorem, and we'll get some practice with that later on. When you add vectors graphically or mathematically, which is the same thing as analytically, sometimes the graphical thing is a little bit of overkill. If they're going along in the same direction, like this example here, where Sue drove 2 miles east to pick up her friend Sam. So here she heads 2 miles east, and she grabs Sam, and then she drives on for another mile. And the question is, how far is Sue from her home? And so if you remember, we're looking for, in this case, for displacement. How far with a vector displacement. You would draw the first one, the equivalent of 2 miles east, and draw the second one about half its size, 1 mile east. And then once you draw them tip to tail, you get the answer being 3 miles east. And so this is her displacement. We have a couple more examples to go through. If you're having questions as we go through, please make notes of these questions on your notes so you can ask in class next time we see you. So here's a case where they're both parallel, but one's going one direction and the other is heading in another direction. And because direction matters, we've got to decide a positive and a negative. And so in this case, we're going to decide that east is positive, and I'm going to call west negative. And so Irene's going to sail, and her boat is moving with a velocity of 3 meters per second east. So here's her velocity. And then the wind is blowing her back. At a negative 1 meter per second west. Let's see if I can get that a little better. Erase. There we go. I didn't want to erase. There. So how fast is Irene's sailboat moving after hitting the headwind? And in this case, since you have the positive 3 and the negative 1, her velocity is going to be 2 meters per second east. I'm hoping that makes sense. You need to draw these diagrams. They'll help you work out the problem. We consider these part of the given statement, that when you list all of your information, we would like to see the drawing also. And then the very last example would be one where we're going to end up building a right triangle. And so first off, Jenny's going to drive 2 miles east to pick up her friend Michelle. And then they're going to turn the corner and head north. So she's going to turn the corner and go north. And once again, it's drawn about the right distance. And then to get the resultant, which would be her displacement from her house, you want that piece right there of your triangle. You're going to use Pythagorean theorem. Or if you drew it very carefully, you could use a ruler. And you would find that she's 2.2 miles northeast from where she started. So this would be her displacement. And we're not going to worry too much about the angles. So you don't have to worry about angles too much. We are going to deal with 90-degree angles. And your directions that you give us, that will be good enough. Something north, south, east, west, northeast, southeast, northwest, or southwest. All right, well, I hope this helps you out. You're going to get some more practice working with the vectors in class. Please come to class with questions if you have any. And good luck.